Hello and welcome to week 3. If you guys have sound problems, let me know because I've been earlier today I had sound problems recording a video. One worked, one didn't, so it's computers. Anyway, so today, this week, we grab the book. We're going to be doing this book right here, chapter 8. Chapter 8 is kind of light, so I supplemented with some additional information I think is valuable and a real quick TikTok video I found last week that I thought was relevant, and some homework. So let's go with that. So first, I guess the professors got an email from the College of Business about grades, and I'm always super transparent about grades. Whatever it shows on Web Campus will be your final grade. If you have questions, let me know. I'm willing to work with you. I'm willing to help you understand your grade. I had, remember, I'm a student, and maybe 2 years ago, I was taking a graduate level class, and the professor in that class, tenure professor in another department, he, I think, handed back 2 assignments out of 10. He also never returned his midterm, so I don't even know the grade on the midterm, and I never know the grade on the final. And I honestly think he just kind of maybe made up the grades. And it's hard because I don't know if I did good or bad. I mean, I know the grade. I got an A in the class, but still, at the end of the day, I'm just not real happy with things like that. So I always try to be very straightforward. I try to grade within 7 days or after 7 days. I have to kind of wait 7 days to make sure if you turn in late, I can be fair to other students. So whatever you see on Web Campus should be your grade or will be your grade at the end. If you have questions, I can help you calculate out your grade. I'm here for you on that. You should never have any doubts about your grade. I'm not a super heavy grader. I told you I'm more about results and more about getting to the goal post. This chapter 8 on this book is not really heavy, but it's super important. Okay, I did supplement some of this. However, the stuff I supplemented, I put links to in the module 3 little readme. Some of it's real light reading, some of it's a couple minute videos. Because, you don't need me to teach you things you can find either on the internet or that aren't going to be directly impacting you for the next 5 years. Something that's not really relevant. Maybe have a cursory overview of it, and that is good enough. Now, when I was an undergraduate, I went to either a conference or a talk, and somebody told me that they wish they had taken more statistics classes. They wish they just knew more statistics in graduate school. And I've taken more statistics classes than is required for my program for anything. Not that I particularly love it, I do, but statistics are vital. All of machine learning is just statistics. Everything we do is statistics, and some part of it is data. Every field is being impacted by data and statistics. You have these SME, subject matter experts, you have these domain experts that are just phenomenal in all these different areas, except for data and except for statistics. And you don't need to be a statistician. I'm not telling you that. I'm telling you to be good at computers and know stats. That's the whole point in data science, is that you can take an idea and test it logically and I guess with evidence. So, this chapter is really important. Finally, everyone's doing good on data on the discussion posts. If you remember, the discussion posts are posts the first reply to my prompt or related subjects by Thursday night. Then reply to your classmates either Friday, Saturday, or Sunday. I've been loving the discussion so far. It's, the discussion post is kind of like the attendance. It's a way to make sure that I know you guys are involved, that you're thinking, you're Googling, you're using critical thinking. So far, the size has been fine. The topics have been fine. Everything's really fine. I'll grade this week's here in a little bit. And number 5, there is homework this week. It's due Sunday night. I think it's the 4th. Don't quote me on that, but I think it's the 4th. Both these homeworks should take you no more than 10 minutes each. The MVP on this homework, okay, what I expect of you, okay? There's 2 videos on it, so you can watch the videos to do it. But the first homework, I basically just want you to change a line or 2 in Python and show me the results. Okay, it's more about learning how to use Colab, learning about processing data. That's all. There's a lot of other things you can do, a lot of other things you can play with. It's related to NLP, which we'll cover next week. But that's the basics of homework number 1. Homework number 2 is a transformer, or the Python transformer library, and accessing data sets. They're both vitally important. The transformer one's important because if you know how to access the data sets, we can go on and access models. We can go on and access additional features of the transformer libraries. So they're both fundamentally foundational homework. Okay, again, they both shouldn't take more than 10 minutes each at the most. They're very easy. Don't worry, it will get harder and you'll learn more, but I just want to make sure you guys are grounded. I know the first couple of weeks of school is chaotic. You know, I'm not going to overwhelm you with a bunch of things, so that's where we're at. Now, you know, I kind of talked about this, but I can't stress enough is that all fields are being radically changed by data. And I mean, I work with a lot of medical doctors, a lot of nurses, and I see it in the healthcare industry. That data is driving the change. It doesn't matter if it's through prescription, through phone calls, through doctors, through EMRs. There's all this data being collected, and there's so much value on it. But so few people know how to take that data and convert to value. So I love this little cartoon. You know, I'll let you read it, but it's super important in any field to be able to take what you love, computers or camping for some of you, and travel for other ones. I mean, I remember reading the week 1 discussions. You guys have so many broad interests. To take, you know, something like that and mix it with data, mix it with computers, you'll be successful. If some of you like archaeology, archaeology has really been taken over by data. Art has been taken over by data. I mean, biology used to be kind of a soft science until the late 90s, until computers got involved. And you're seeing this paradigm shift in a lot of different fields. So it's super valuable. That's my quote. So let's start with Hadoop. Hopefully the sound.
I mean, 5 years ago, it used to be the same 3 requirements. You know, you had to be able to do Hadoop. Was like in every single job description, and you had to be able to use MapReduce, Pig, and Hive. And you would talk to the person on the phone. It's like, do you really use Hive? I have no idea what that is. I was just told to put in, and everyone was copying everyone else's job description because no one gave them a straight answer. So it isn't always their fault.
So you mentioned all these tools. How has that changed now?
I think it's a lot better. I don't see nearly as much Hadoop in the ads, and I think that people have gotten better at posting the type of tools that are closer to the job that they're actually going to be doing, which is really helpful for all of us because we also know what to answer the question.
Okay, so why? I don't even remember. I found it last week or the week before, and it's in my opinion, very, very relevant. I told you about that job that UHG sent me last Wednesday, or whenever I got it. And that's literally, that's a very common process where they have some type of Hadoop instructions. They'll give you, like 5-page instructions. Here's how to run it. Here's a command to type, blah, blah, blah. And you run it once or twice a year. You get data, and then you do something else with that data. Currently, at least in my mind, there's either you do Hadoop 90% of the time or you do it 1% of the time. I haven't used Hadoop since, I don't think I'm talking about work 2022, okay? I've used a couple other large file systems, large distributed networks, things like that. But actual Hadoop hasn't been, it's been a while. And there's no one reason for that. I mean, computers now are faster. There's we can spin up more processes on Azure. There's a lot of different reasons, but it is what it is. Some of the videos that I posted that you should watch, talking a little bit about the history of Hadoop, how Amazon use it, how Yahoo use it, things like this, Google use it. So if you really kind of get it down to, I know we talked lightly about Hadoop, but Hadoop kind of has, I'll say 3, maybe even 2 major parts you heard about. The file system. The file system was a fundamental change in the way that processing happened 20 years ago, 15 years ago. So instead of having one chunky large file here, we can distribute it to multiple places. We can break it up logically, and not maybe logically, but we can break it up to keep track of those chunks and send it to different nodes, and then each node can process that. If a node goes down, we have hardware failure, we can just recover without a problem. And a resource negotiator or a resource manager, Slurm, there's a bunch of them, PBS. There are ways to say, hey, these nodes are working, this computer's working, oh, that one died, okay? And MapReduce is a way to kind of convert data into key values, to keep track of it, to shuffle data to make sure if any particular one thing fails, that there's redundancies, and also to kind of add the jobs back together. So let's go a little bit more in detail. So I had another slide last week. If you look at last week's slide, I had a different picture here. I chose this one specifically because it's the same slide with a different picture. So, 100 terabyte file, and honestly, 100 terabytes is, I don't think that large. Maybe it is. But, I mean, you could run that on Amazon without any problem. And then basically, you break that down to maybe 10 gigabyte files. You're going to have more because of redundancy. You see the blue files on maybe computer A, computer, well, hey, 1, 2, so it's on computer 3, computer 4, and maybe computer 6, maybe computer 7, and maybe computer 9. I don't know, I should have labeled them or something. So you see how we break it down. And this is where I got that link from. You can go a little bit more in detail. But it basically shows you, hey, we take a very large file and break it down into multiple parts. We can't really do this with our traditional file system like NTFS or other file systems readily. We can't take a picture and cut it into parts and give some here, give some there. It doesn't work. Okay, we have no real way of tracking it. Last week they took down that video, and I found this is a really good video. So this is another video I found. I still can't find this video, but it's so good. It's so good. Look, I have a misspelling there. I guess it's not a misspelling, it's just a bad crop. I cropped it incorrectly, so there you go. So anyway, there's another video here. I posted on the module 3 to do it. It's a really good video. This is the history of MapReduce, kind of basics of it. It's a really good video, so I recommend you watch that. So we talked a little bit again about the library analogy last week. I just kind of want to go over it so you have the concept of how it works. Okay, so the mapping task, the task. Okay, imagine each librarian is in a library and is given a section of books. They go through each book and write down the author's name and how many books that they see. I guess kind of so Young, Lee, Thomas, Jones, Young. So they basically count that. They write down each one of those things. Okay, then as a backup, I might go over to another section just to verify the other librarians' count. Okay, but I have a list of all the books and basically a 1 next to it, because I'm just counting it one time, adding it, counting it one time next. Then the head librarian counts how many books are for each author, like a reduced task. This is where the data is summarized, counting books per author. Okay, so really, that's kind of the way it works. We divide the work to multiple people, and then somebody kind of summarizes it all together. And I need to maybe find a better analogy. That's a great discussion topic. Explain MapReduce via analogy. But we can do this type of things with work, with labor, with Python, with Java. Which is that it was first done with Java, and there's a paper that explains how Java did it, or how Google did it. And there's tools that were designed to do this. Now there's other, AWS has tools that can do this. Azure has tools that can do this. But once you get the computational idea, once you can imagine how it works, then it can be applied to a multitude of different systems. Because MapReduce is not inherently really that fast. There's a video that I have posted talks about the difference between MapReduce and Spark. So there's that. There's some additional terms. So Pig-Latin is kind of like a programming language that has an interactive prompt. I like it. I think it's a little easier to code. So you want to do some type of task in a Hadoop environment or on a cluster. You can write in Pig, or Pig-Latin, I guess. And it can give you an interactive terminal. So if you can't remember before, Python, you used to have to write line by line, run it, write it, run line by line, run it. It was horrible. With notebooks now, you can break it down to sections. Okay, that's more of an interactive environment. That's kind of how Pig-Latin is, but not in a cell-based method. It's an interactive method. So you run one line, see if it works, write another line, run it, see if it works, and build there. So that's kind of Pig-Latin. Hive is just kind of a way to track data almost. It's a Hive. I wrote that it's like an SQL-like interface to store data, but it really has nothing to do with database. It just has to do with, hey, where's this file? Is it local? Is it distributed over a network? How am I going to get this file system? And finally, Spark is just designed for faster computation because it can move the data into memory. There's other ways to do faster processing with Hadoop. You can do like RAM drives, and there's ways to kind of speed up Hadoop. But Spark is generally faster just because it's newer. So it's API based in some ways. So those are just some of the additional terms I wanted to cover that you might see. The videos will cover a little bit more in detail. Don't stress a ton about Hadoop because, I don't want to say it's on its way out, but, if you're going to do Hadoop, you're going to spend years learning it, loving it, just breathing it. But in a business sense, that's not really what happens. In a business sense, you might run it once or twice a year, if that. You get the data from it and you derive additional information down the road from it. So, Chapter 8 talks a little bit about quantitative and qualitative analysis. I believe those terms the book uses. And you really have to think about what that is, because whenever you go into a project, whenever you work on anything, you have to think what type of data in theory am I getting. And normally it's not one of these, it's both of these. Okay. On bigger projects, you'll get a bunch of quantitative data points, numbers, ratios, percentage, change year over year, things like this. You get numbers. But then you also get qualitative analysis. You'll get why it's better. So an NPS score is, let's see if we can. So an NPS score is measured with a single question survey and is reported with a number ranging from -100 to 100. It's often used as a gold standard by customer experience. Okay. How likely is it that you would recommend Google to a friend or colleague? Okay. Now, NPS by itself is a quantitative value and quantitative number. But a lot of times companies will add, why did you give us this score? Qualitative. What made you give us that score? How can we get better? Those are normally what you see in the real world. You see a true hardcore number, and then you see qualitative values around it. Now remember too, that currently maybe 50 to 80% of the data in the world of data science is this, but honestly 80% of the data is this, and we have to figure out how to take this data and move it over to something we can use. Well, your book talks about A/B testing, and it doesn't do a good job of A/B testing. A/B testing is so valuable because there's different ways to think about A/B testing. Okay, you can think of A/B testing as just a simple, hey, on a website, I have two different things, and I'm going to make a different, picture. And out of those different pictures, I'm going to get different results. I'm going to compare the two. But that's just the basics of it. Once you really get A/B testing, hey, I have two machine learning models. One gives me a better result. I'm using linear regression, a ridge regression versus a traditional, just a traditional linear regression model. What one gives me more accurate results? Okay, I'm wearing red every day for next week, and then after that, I'm wearing black next week. Ways to test and interrogate our environment and our world. This is what science is about. This is what data science is about. This is what hypothesis testing is about. As a business, if I did this, would I make more money? McDonald's is releasing some new restaurant, Cosmac or something. Why are they doing that? They want to know if they're going to make more money. It's not like they're bored and say, hey, I want to make a new restaurant for no reason. They're going to try to do this to make more money. Everything that bigger businesses do generally should be driven by an experiment that shown some type of feasibility, an A/B test, then they scaled it. So this was one of the very first ones that I can remember years ago that really impacted me. During the Obama campaign, and I think I put more links on this, The Obama campaign used just a different word right here. 11 different variations, I believe it was. Okay, so they found that the learn more resulted, the clicking of the variation went from 8% to 11%. Ooh, big deal, 8% to 11%. That's a 40% increase in signups. And with an average $21 donation during the length of the campaign, they were able to net about 3 million more email addresses, and that results in $60 million worth of additional donations. And you can read more about different A/B testing. The one I remember from years ago was that picture of him, and then they had a black and white picture, and the black and white picture did better. I think there's some TV shows, about this. So A/B testing is just so vital in so many ways, and your book just doesn't do it justice. But with machine learning, testing different models, with statistics, testing different models, where both are valid and good models, what one nets results that show the most promise. The time series, this book talks a little bit about time series, which we're not going to go into, but time series is such a complex field, and sometimes you have 2, 3, 4, 5 models, and what one's really the better one. We can use A/B testing and plus some other metrics, and so I really encourage you to read up about A/B testing. But A/B testing simply is, hey, we have 2 web pages, for example, and we're going to change one controlled variable. We're going to change one thing and see what the difference is. I'll put that in here. So remember, your book doesn't talk about this. I'm hoping you guys all know this. An independent variable, okay, is one thing you change. The dependent variable is kind of what you measure, what you see. What if I change A, what happens to B? B is a dependent variable. The one thing, I'll just read it. The one thing you change to limit limit it to only one experiment. And there are other ones that you can do multiple regression, but you get the idea. So if I have a plant and I give it water or soda or juice, how's that going to affect the growth? Okay. A/B testing. I have soda versus water. I have maybe juice versus water. And I know if I give the plant soda versus water, maybe it grows twice as much. Maybe I get a Red Bull. It grows twice as much. Okay. Another slide I love. Independent variable is the cause, what you change. Dependent variable is the effect. And I know you guys have had this before. I know you're all graduate students. I cannot stress this. This needs to be, anytime you see anything, anytime anything happens, always independent and dependent variable. Because in business and life and science, people get these things mixed up. They'll change 2 or 3 different things. They won't think about confounding factors. What else changed? Okay. Your book talks a little bit about linear regression. I'll be happy to go into linear regression, but in a nutshell, linear regression is you're just kind of taking one variable, trying to look at predicting another variable. Okay. This is an old slide I have, predicting house values based on a feature like size or location. I mean, that's multiple linear regression. Number of bedrooms. Now I know a 1-bedroom house goes for 100,000. I know a 2-bedroom house goes for 200,000. I know a 3-bedroom house goes for 300,000. What do you think a 4-bedroom house is going to go for? My brain, linear regression, $400,000. Nothing's ever really that easy, but you get the point. Your book talks a little bit about the difference between classification, clustering, outline detection, and filtering. I'm just going to hit classification and clustering real quick. Outline detection and filtering, they're important, but I really want to just focus on classification and clustering for right now. So classification, in a nutshell, all it is labeled data. Okay, you have one type of label that you're trying to predict something else, you're trying to know something else. Okay, you have an input and an output, and you say, hey, if I give you this, this is what I'm going to get in theory. Okay, regression is one of them. Classification, there's a bunch of different types. If you remember, hey, supervised learning, I'm dealing with labeled data. So if that's the case, what's unsupervised learning? It's clustering. Okay, if I have unsupervised data, if I have unlabeled data, what can I do with it? We can kind of break it apart. Do that. You can kind of cluster it. But that's kind of unsupervised learning. A couple other words that your book kind of talks about: NLP. So NLP, natural language processing. Um, I don't know if I'd call it a branch of artificial intelligence, but it's a branch of computer science or data analytics that focuses on enabling computers to kind of understand the human language in valuable method, in a valuable way. Another term your book uses text analyst and text mining, or they use text analytics. I use text mining, but it's the idea of here's a corpus, here's a body of words, and I want to be able to pull meaningful information out of that. Now, it may not be meaningful in a business sense, but at least we can pull some type of meaningful information out. Now, what do I mean by that? So if I give you war and peace, and I want to know how many times the word war is in war and peace, I want to know how many times the word peace is in war and peace. That's a mouthful. That is basically text mining. That's text analytics. Okay. Sentiment analysis. So that is the idea of figuring out if a statement, a paragraph, if some amount of text is positive or negative, or happy or sad. The book doesn't go into happy or sad, but it can also do happy or sad or anger. Those are a little bit more complex terminologies, but you can look at things like that. And, I'm sure Hugging Face has a couple different models that we can look at. And just computational linguistics. That's just a study of all this stuff. I just didn't want to have 3 slides. I think it looks ugly. In my last class, I talked about power visualization. And so, for us humans, we spend an enormously large amount of energy in our brain for visual processing. So, you guys know that I'm a neuroscientist. I study neuroscience. I study the brain, and I say how the neurons interact, much like machine learning. Machine learning is silica, a machine doing it. Neuroscience is humans doing it, or kind of the fusion of the two. Now, I can tell you that out of most of the species on the planet, I hate to generalize, we spend an enormously large amount of brain power on visualization. Okay? So, if we can communicate, pictures worth 1,000 words, if we can communicate visually our data, we'll be years ahead of our competition. Okay? I'm just going to pull up a couple of visualizations real quick. And you can kind of see really quick that, hey, garbage in the ocean. And you can really kind of understand what people are trying to communicate, what people are trying to tell us. And some of this is really big data, some of it's not. So smaller countries are beautiful. 195 countries, which is a lot of data, are measured across 8 different attributes and given a grade of 1 to 7. There are 78 small countries on the left with populations up to and including 5 million. The remaining 117 large countries are to the right. So higher scores, lower score. So generally speaking, if you live in these countries, you're less likely to be happy. Happy is a word. Beautiful. Oh, no. I think they're talking about happiness as score, but I'm not 100% sure. But these are smaller countries where people are happy. These are larger countries where people are happy. In just a few seconds, you can consume this information. There's also a Viz of the Day. Again, I recommend, I think I saw a baseball one. I know you guys are into sports, Walt Disney movies. That's nice. It goes right to the movies. Interesting. So, animation versus action, comedy, the second, Beauty and the Beast. So, yeah. So, again, your book doesn't really go into the power of visualization. People spend their whole life doing visualization. There's some, people that just do amazing visualization. So, you can have big data, but if you can't communicate the value of it, it's useless. So, again, if you have any questions about your grade or anything else like that, please contact me. I'm here to help you with that. I want to see you succeed. Everyone's doing great so far. I'd like to keep it that way. Big data terms I put a couple videos on there about Spark and Hadoop. Watch the video. Some of you don't have to watch all the way. Maybe take notes of just the big words and, hey, this is what Spark is. This is why Spark is better. A page note would be more than enough for anybody. Or watch a video 2 or 3 times and remember it, either way. BDF Chapter 8, which is what we just finished, the Big Data Fundamentals. Kind of light chapter, but again, the chapter kind of relates 2 important fundamental concepts that, hey, statistics and data are super valuable. And that somehow we have to do something with that. We have to visualize it. We have to predict. We have to do something with it. Everyone's doing fine on the discussion post. The discussion post comes out on Monday. Post by Thursday. Reply to me, or cite your source if you have web links. If you use ChatGPT, say I use ChatGPT, or I use Gemini, whatever you use, just cite it. Then Friday, Saturday, Sunday, respond to one of your fellow classmates. There's 2 homework assignments. Both are 5 points, super easy. Shouldn't take you more than 10 minutes to do it, to at least get an MVP. You can do it multiple times. I don't keep check or grade the first, second, whatever the final post is. That's what I care about. Okay. If you do more, that's great. I'm never going to mark you down. If you have problems and can't get it, and for some reason you don't want to contact me, but you try to do something similar, that works. My goal is to get you to the goalpost. And the goalpost for homework number 1 is to be able to load a fractional part of a data set. Okay, and just kind of see the data process and understand the Python, kind of understand Colab. Okay, my goalpost for number 2 is to load a data set, to load 2 data sets. If you can't get data sets to load, but you've got a model to load, I'll take that. The goalpost is, hey, here's a transformer library. Hugging Face can do all these cool things, but to do all these things, I have to get to my local environment or my environment. Hence transformers. So that's that. There is a video up of the research idea proposal. I don't think it goes live to the first day of the month. Basically, that's from last semester, but it's the same idea, same thing. If you could research anything, if you do anything you want, what would it be? I want you to communicate that idea. I want you to articulate that idea to me in written word. If you could do anything you want with either, the data was available, I could do this, what would you do? So, and also guys, this week's discussion post on data privacy, data utility, you guys blew my mind. I am so impressed. You guys are doing great. So if you have questions or thoughts, I'm here to help you. If you have prompts to the homework, don't get frustrated. Contact me, email me. I can either record a video, we can meet on Zoom, whatever you need. Mondays and Tuesdays are a little busy for me. But other than that, I can do mornings, I can do evenings, I can meet on campus. I'm on campus on Thursdays regularly, and I think Fridays now. Let me know how I can help you. I want you to succeed. This is exciting stuff, and we're about ready to hit NLP. We're about ready to tackle this book right here. Okay, and things are going to get a lot more fun. So if you have questions, hit me up. Try to do the homework. You can use Google, you can use ChatGPT. It's not a whole hard homework assignment. Things will get harder as a next couple of weeks, but breathe. Everyone's doing fine, okay? Thank you.